6.1. Question number 1. We need to find a value of.
और ये ऐसे बच्चों को जरा मैं सेटिंग करके दूंगा ये और कम
Keep this in mind. Here we have to differentiate Q with respect to temperature, and this P denotes that while differentiating Q with respect to temperature, we should treat pressure as constant. Same way, in this particular expression, while differentiating Q with respect to temperature, volume should be treated as constant. Just use this value, substitute U by delta U by NCV dt and proceed forward. Keeping the constant into account, you reach to the answer. Question number 2. We have to find out a reaction which is accompanied by absorption of energy. Burning of candle, we all know that candle burning is a combustion reaction, and in every combustion reaction, energy is liberated. So energy can't be absorbed in this reaction. Rusting of iron, it is a well-known exothermic process. So energy is liberated in rusting of iron. Energy can't be absorbed. As far as electrolysis of water is concerned, for electrolysis of water, in order to electrolyze water, I will need to break the bonds of water. For that, I will be needing energy. So electrolysis of water will be an endothermic process, and this is our desired answer. Question number 3. Question number 3. For the given reaction, the heat energy change during the chemical reaction will be heat of combustion of CO. Of course, it is heat of combustion is the heat involved when 1 mole of the compound is burned in excess of oxygen. And in this particular reaction, 1 mole of CO is getting burned. 1 mole of CO is getting burned in the required amount of oxygen. For this particular reaction, the delta H for this reaction will be equal to delta H of for combustion of CO. Let's move to question number 5. Molar heat capacity at constant temperature. Now see, delta Q is equal to NCV dt. CV is equal to delta Q upon N dt. And here will be delta U, and Q is equal to NCP dt. So Cp will be equal to Q upon N dt. If temperature is constant, then dt will be equal to 0. If dt is equal to 0, both Cv will be equal to infinite and Cp would also tend to infinity. So both of them will be infinite. Proceeding to question number 12. Question number 12. I have heat of neutralization of few acids minus 13.7. For B it is minus 9.4. For C it is minus 11.2. And for D it is minus 12.4. And I have stated in class also, that your teacher might have stated in a class, that heat of neutralization is maximum for strong acid. So A will be the strongest acid of them, because A is having the maximum heat of neutralization out of these four. It will be followed by D, which will be followed by C, and that series will be trailed by B. So this will be the order.